Namaste, dear students. Today I have a very interesting problem from the MSTAT PSA paper, and this is the problem. So suppose we have a bivariate sample that is x1, y1 up to x9, y9. So we have 9 observations, 9 bivariate observations, where you can consider xi to be the covariate and y as the response. And we are trying to fit this equation or this line to the given data. Now, it turns out that the fifth observation was wrongly recorded. So it was wrongly recorded. Now, when we revised or like when we correct, so we will have to do the whole calculation again, right? Now, the question here is what changes will happen in the new fitted line after that one observation is moved? Now, if you see very carefully, we have 9 observations and the response for the fifth observation was recorded wrongly. So like also we are given the covariates as xi equals I. So the x points, they are equally distant, equidistant points, right? And we have this. So this is the corresponding covariate for the wrongly recorded observation. Now this is the property of a regression line that it passes through the point x bar and y bar. So basically there will be no change as we will see in the slope because this will not contribute in the slope, rather this point will contribute in the intercept arm of the fitted regression line. So why is it so? Because like it minimizes the distances of the fitted line from the observed observations. And if something is lying over here, if something is lying here, then basically it will not contribute because we are actually taking average of the responses, and the average has a certain weight, and that weightage is the difference of the covariate value from the average of covariate value. Now for the central observation, that is y5, that particular weightage value is exactly 0, so it just vanishes. So this is the idea. Okay, let me formally explain that. So as you can see, these are the formulas for the intercept and slope of a regression line with just one covariate, right? So now if we put xi as y, xi is equal to I, then we will obtain certain formula for this, right? And this is that formula. So beta 1 cap is summation I minus 5 times yi divided by summation I minus 5 squared. So this is that simplified form. This is that simplified form. But as you all can note, this particular form has no term containing y5. Why is it so? Because we are giving the weights as I minus 5. Now this I minus 5 will become 0 when I equals to 5. So no contribution. And that is the reason the beta 1 cap term will have no term including y5, right? So whatever be the value, how much change is there or whether it is wrongly recorded, there is no contribution in the slope. But in the intercept, we can see there is this y bar term. So even though this term is changing, or I should say it is not changing, but the y bar, that is the average, that will definitely change because one of the observations are being changed, they were wrongly recorded. So definitely the slope will change, the intercept will remain unchanged. And hence the answer should be A. That is, intercept can change, but slope cannot. So this is the correct answer. Okay, so this is a very interesting and it is conceptual kind of, and the main concept is how we get the coefficients in a linear regression and how we consider those coefficients as a weighted sum of the observed responses. So that is the key idea. Okay, so this is all about this video. I hope you all enjoyed it, and do consider watching other videos in our channel. Thank you very much. Hare Krishna.